Great. We are now live on YouTube. I will update it. It's actually, here, let me hand the host back to you.
Oh, okay. So now it's live on YouTube?
Yeah.
Okay, cool. So good evening, everyone. Welcome to Hyperledger Toronto meetup. So today we'll invite Tomisin from SecureKey to talk about the future of digital identities. So I wonder if any of you work with Hyperledger Aries. So Hyperledger Aries, it's a decentralized identity management platform. So Tomisin will talk about how Aries can make digital identity management simpler and more scalable. That will improve user experience. Before we start, we have a September survey. So we'd like to collect some information from you guys on some feedbacks or if anyone have worked on the projects, Hyperledger related project, or would like to be a speaker in the future, you could share with us and we'll take a look. And also we plan to host a networking event. So we have some different styles that we're planning for. So it'd be nice that if you share your feedback on how you would like a networking event to happen, that'd be great. Okay, so Tomisin, are you ready?
Yes.
Okay, so I'll pass it to you. You can share your screen. Okay, great.
Let's share this one. Okay, I believe you can see my screen now.
Yes.
Okay. Good evening, everyone, and thank you for attending tonight's meetup. We'll be looking at the future of digital identities. So my name is Tomisin, and just a quick intro about me. I joined the blockchain industry during the crypto rush, which happened a few years ago, that I'm sure many people are familiar with. And at that point, I realized there was more to it than just cryptocurrencies. And I was really interested in the underlying technologies. And then I started working with startups and other companies around the world and decided to actually take the leap and do this full time. So in that time, I've come across different kinds of technologies and implementations and realized the importance of digital identity. So most recently, and with respect to Aries, I've worked with and contributed to the Aries Framework Go library, which is the Golang implementation of Hyperledger Aries, which was developed and is still maintained by SecureKey Technologies and is also open source. So anyone in the community is free to contribute to this project. More specifically, because Aries has several components to it, I focused on one of these components, which is the mobile bindings. So Aries Framework Go is developed in Golang, and we realized that we could actually export this to other platforms. So primarily, you would run your Golang code on the server or within a library that you could use as a CLI or something else. There's a JavaScript implementation that is derived from Aries Framework Go, which is WebAssembly. And what we did was to extend Aries Framework Go to mobile platforms. So that was my focus. And the components of this, what Aries Agent Mobile was about or is about, is it provides native mobile bindings for the Golang library. So that's Aries Framework Go. And by native, I mean it's only for Android and iOS applications that are built with Java or Kotlin on the Android side, or Objective-C and Swift on the iOS side. And this actually supports local and remote agents. So you could actually use this Aries Agent Mobile to generate Android SDKs and iOS SDKs. And within those SDKs, you have the ability to run an agent on your device or to connect to an agent running somewhere else. So the Aries Framework Go can also be used to start a router or to start a server. And finally, Aries Engines Mobile has custom handlers. It supports custom handlers for event notifications. So later on, we'll discuss about DITCOM and communications between agents within the protocol. And this mobile library allows you to have your own handlers for events that come in. Okay, so tonight we'll primarily be looking at three things. First, we'll go over the existing solutions of digital identity today. And by existing, I'm referring to blockchain solutions. Then we'll look at digital identity as I see it for the future. And then we will briefly discuss about how we can get there. How can we get to this promised land, in quotes? Okay, so today's solutions. Identities on current blockchains usually come in two forms. The first you'd see in private or permission networks like Hyperledger Fabric and Corda, where you have X509 certificates. These are very similar to what exists on what you would see in your browser or on a server in a traditional application. And we have the Bitcoin and Ethereum style, which uses asymmetric public keys, asymmetric keys. And what you notice is that these usually are accessible via a node or a central backend. So this is typically what a Hyperledger Fabric identity, how it will be created and how it can be revoked. So in the deployment of Fabric, you would have an entity called a certificate authority. So this certificate authority usually operates within the context of one organization. And that allows the organizations to control the issuance of identities that can represent them. So you can see this CA issues a certificate, a digital certificate, and there's a public-private key accompanying it. And of course, the principal would initially first request a certificate and it can be issued. CAs, certificate authorities, can also revoke certificates. This allows them to control these identities. However, in the context of Ethereum, there isn't really a revocation list on the blockchain itself. You can create a revocation list within your smart contracts, for example, a simple map in your Ethereum Solidity smart contract to prevent certain addresses from accessing it. However, the main idea is to use asymmetric key cryptography. So on Ethereum and Bitcoin and similar blockchains, you usually have identities represented with private and public key pairs. So here we see Alice signing a document using a private key that generates a ciphertext that can be verified by Bob using Alice's public key. So as you know, the private key is something secret that Alice keeps and never publishes to any to the network, but the public key is available for everyone to use. Then we have the context of browser extension wallets. So we're getting into the phase of user adoption. So the previous slides have described the low-level protocol layers. However, not everyone has the capacity or should access the lower level. So we have the application layer, which is the browser in this case, which will have a crypto wallet installed in this browser. So it's more common with public blockchains. It's rare to see this with a private blockchain. And the wallet is usually created on the client's browser, and it can also be disabled. This allows for decentralized applications or dApps to have access to a blockchain. And these wallets in the browser provide interfaces that allow a dApp, which is just a website that can access the blockchain, to get access to the keys stored inside the wallet. So typically, this is what it would look like in this two-tier architecture, which was sort of popular between, let's say, 2016 and 2018. The misconception that we had in the industry was that it was enough to have a client that would connect directly to the blockchain. So of course, everyone is familiar with this three-tier where you have the application, you have the presentation layer, application, and data layer. What Ethereum provided with the EVM and smart contracts was a combination of both application and data layer. So smart contract logic was combined with data on the blockchain. And what we assumed back then was that by injecting a wallet into the browser, we could have direct access to the blockchain. So it does work. However, the question is, what's wrong with this approach? For one, it's not scalable because of the block times. On the mainnet, we know it takes quite some time, sometimes up to several minutes to get the transaction confirmed. And some of these wallets rely on centralized nodes running Ethereum. And one example of them is Infura, which is used by MetaMask. MetaMask is the logo that you just saw. Apart from this, it's also not secure because it depends on the browser's security and the application security. So many browser applications, web apps, will be built to JavaScript. So this means any attack that can happen with JavaScript, that can happen on a JavaScript application, can eventually bubble up into the wallet. So it's possible for people to inject scripts on a poorly written application that would steal private data in the wallet. Also, this doesn't provide a native mobile experience. The reality is that we're heading to a point where most experiences for services provided by companies are delivered through mobile devices and not through websites. What this means is that we also need to find a way to connect mobile devices to the blockchain. However, when you have something really slow, you have an application that's really slow, it's really difficult and frustrating for users to interact with your application and your product as a company. Apart from not providing a mobile experience, apart from being slow, what you'd see happening is that many of these mobile wallets are actually just browsers. They are mobile apps, but the mobile app is a browser with a JavaScript wallet injected in there. So what's actually happening is you're not really using a mobile app. You're just using a browser and accessing different dApps, decentralized applications. So you're just switching between websites. So what you're really doing is using a responsive view of your website on your mobile device. So that's not really a native mobile experience. Then, in order to address the scalability issues, suggestions were made to modify the protocols themselves. So with Bitcoin, there's the concept of SegWit2 wallets, which are segregated witnesses. The witness really is the transaction signature. So the idea here was that in order for the users to connect directly, for the mobile apps to connect directly to the blockchain, the easiest thing to do was to reduce the amount of data they have to store, which then means that you have to, in this approach, the transaction signature is removed. However, when the transaction signature is removed, you can be sure that even though you're able to receive a lot of transactions, you really have to put trust in the node that is sending in those transactions. Then there's the concept of SPV wallets, which are single parent verification wallets. These rely on storage. They store, these rely on block headers from trusted nodes, and they store those block headers. So this reliance on trusted nodes provides a central point of failure and also a central point of theft or bad actors. And with SPV wallets, the mobile app is actually able to validate its own transactions. However, this can also lead to fraud. So one interesting thing about SPV is that it was included in the original Bitcoin white paper. So these are all different approaches to scaling blockchains to make it easier for mobile devices to connect to a decentralized ledger. Then finally, we have the API wallets. So the API wallets are the more centralized approach. You'd have your client application that connects to a central backend run by a private company whose code is not open source. And within that server, that backend, there will be connections to the blockchains. Now, what this means is that the keys are not stored with the client. The keys are actually stored in some data store or database on this backend, on this server. So if you don't have the keys, they're actually not yours. You may have an account that maps to some key in the database, but as long as you don't have the private key, it's not yours, which means it's not your cryptocurrency, which in the concept of self-sovereign identity means it's not your digital identity. What this means is that we reach a certain scalability we reach a trilemma or a dilemma. It's called the blockchain scalability trilemma, which is popularized by Ethereum's founder, Vitalik Buterin. And what this trilemma says is that out of 3 items, you can only pick 2. So the 3 items are decentralization, security, and scalability. So it says that you can have decentralization and security, but not scalability. So on this side, you see networks like Ethereum and Bitcoin. They are secure and decentralized, but they're not scalable. Bitcoin can only output about 7 transactions per second. You can have scalability and security, but you can't have decentralization. And then you can have scalability and decentralization, but you can't have that security. So this trilemma makes it really difficult to build applications that use blockchain technology, and to also build them without having the users have intimate knowledge of the underlying protocol. So what do we really need? We need solutions that prevent double spending because of the transfer of digital items. We also need tamper-proof identities, tamper-proof identity processing, and of course, a lot more. So this is where Hyperledger Aries comes into play. Hyperledger Aries is a project that is focused on the creation of agents that allow mobile devices or any other kind of device to send documents, verifiable documents, without having an intimate relationship, an intimate connection to a decentralized ledger. This means that Hyperledger Aries is blockchain agnostic and can be used on top of any distributed data store. So it doesn't even have to be Bitcoin or Ethereum or Fabric. It could also be some decentralized ledger. Now, the key concepts of Aries include DIDs, DID documents, DID resolvers, verifiable credentials, verifiable presentations, agents, and of course, DID communication. So firstly, decentralized identifiers. So we need to look at the difference between an identity and an identifier. An identity is an individual. It's a subject. It's you and I. That's the identity. An identifier is what we publicly use. It's a name or some other reference to an identity. So my name, for example, Tomisin Generala, that is an identifier. My driver's license is not my identifier. My driver's license is an attestation made by the government, which says I can do X, Y, Z, and I have the role of a driver, maybe G1 or G2, and so on and so forth. So by understanding identifiers, now we can think of decentralized identifiers. So DIDs are a new kind of identifier which enable decentralized digital identity. What this means is that it's decoupled from the centralized registries. Your digital identity doesn't have to be issued or verified by a centralized authority. And what we know is that if there's a centralized authority who's in control of the definition of the identity, the definition of the identifier, the issuance of this identifier, how the roles that this identifier has, it's very unlikely that the true identity in the real world has any control over what these items are used for. So generally, a DID will look like this. This is some implementation detail. We usually have 3 sections. There's a scheme, the namespace or method, and then a specific identifier. So what you'd see is that this scheme maps to some, this DID can map to some decentralized identity document. So these documents, these DID documents, are data that describes the subject of a DID. And they can contain attributes or claims, such as, like I mentioned before, like a driver's license, for example, or even things that say, okay, Tomisin has completed a Bachelor of Science in Computer Science. And this is an example of what the DID documents could look like. So these are just implementation details. And at the level of the protocol and in the code, this is what will be passed around. Then we have DID resolvers. We've spoken about how DIDs map to a DID document, but how is that mapping going on? How is that function? What is that function that does the mapping? So DID resolvers really just perform the retrieval of a DID document that is identified by DID. So in a possible deployment, this is what you'd have. You'd have your application that has an idea of that knows a DID, a specific DID, and then it points to some resolver. This is one example of a resolver. This is the universal resolver that resolves any kind of that is designed to resolve any kind of DID. So this resolver would have its implementation detail. Within its implementation, it would know how to find the specific data registry where the document should be. So this app is trying to get a specific DID document. So it passes in a DID here, and then the resolver will figure out how to retrieve this document and how to present it to the client. So this resolver relies on the read operation applicable to the applicable DID method. So the DID method is really just this section. So in the method, what we're just saying is, okay, there's a specific implementation of a verifiable data registry, and that's what this implementation is. Now we have the concept of verifiable credentials. So verifiable credentials usually contain these components, but are not limited to these components. You have some metadata there. You have the actual claim and the proof of this claim. So in real life, a credential contains information that tells you something about an identity, or that tells you something an identity has done. So a verifiable credential is a digital representation of a physical credential. And this digital representation can contain the same amount of information that is in the physical one. The advantage here is that it can be cryptographically verified, which means that it's tamper-proof. And it can be used to build a verifiable representation. So what will that be? So verifiable representations, or VPs, have this structure. Again, there's some metadata. It contains a verifiable credential, and then there's some proof in there. So a VP, a verifiable representation, is usually derived from one or more verifiable credentials, and it can be issued by one or more issuers. And usually it expresses, or always it expresses, select portions of personal data that are appropriate for a given situation. So a verifiable representation would not contain data that does not need to be disclosed. For example, if the context is me presenting my driver's license, my verifiable representation, and in that context, if all they need to check is my driver's ID, the presentation would not contain data about my date of birth or country of origin or things like that. Now we have Aries agents and DIDCOM. So Aries agents are a delegate of an individual identity. So what this means is that they can hold cryptographic keys to prove this responsibility. So these agents would usually live on maybe a mobile device or some cloud service. But the advantage here is that by having them on your mobile device, you can be sure that you're in control of the keys that represent your identity and not a centralized service. And agents have the ability to interact with each other over a protocol known as DITCOM. So DITCOM is short for DIT communication, and it ensures secure and non-direct human communication. And by non-direct, what we mean is that you could have two users, maybe Alice and Bob, and Alice might just click on a button, and that would send some information from her mobile app to Bob's mobile app. And both of these apps can have agents in them. This means that they will just be communicating back and forth through a series of events and passing documents with each other. So DITCOM usually would have, so when we look at DITCOM, we know that there are different Aries protocols. So it tells us what to do with the content of each message. And then there's the envelope, which specifies, which is the method by which the message will get delivered. Now we have the self-serving identity stack. So they're essentially 4 layers, and they're divided into 2. The lower 2 layers rely on cryptography. The higher layers rely on trust to humans. So that's layer 1. We have the actual public blockchains or even private blockchains. We have these blockchain or decentralized distributed ledger technologies that are the actual data stores. Then just above that, we have public DIDs. And in layer 2, this is where you have DITCOM protocol. So with DITCOM protocol, like we've just explained, you have agents that are sending information back and forth. So agents can have connections to multiple agents. So within this mobile app, on this mobile device, what you have is an agent plus a wallet. So it's in the wallet that you have the cryptographic material that represents the identity of the mobile app user. The layer above is where you would have credential exchange. So this is where humans come in. So a holder or an owner of the holder of the device would ask the issuer to provide them with the credential. The issuer will issue this verifiable credential on their behalf, and the verifiable credential will be converted into a verifiable presentation, which would contain a proof that is then sent to a verifier. And the verifier is able to approve this presentation because they trust the issuer. So each of these entities will have their own agents. And finally, at the top layer, this is where you have the governance frameworks. So the governance frameworks really just define how within the mechanisms and incentives for how a specific system should run. So we have some trust anchors, credential registries, we have auditors at this layer. So on the top 2 layers, we really rely on human trust. And down here, we rely on cryptographic trust. And what's the benefits of that? There are fewer things that could go wrong at this layer, because all that is happening now on layer 3 is just the exchange of credential. The management of the identity or the implementation and the storage of the wallets, of the keys in the wallets, is now handled by Aries. So the first project in the Hyperledger community or garden to go after identity was Indy. And Indy is a composite and all-in-one DID project. So it's actually spanned across layer 1, 2, and 3. So the problem with this was that it's made many developers and institutions feel that there was a large learning curve and that digital identity with Hyperledger could only be handled with Indy. So what was done was that Indy was broken down. So now you see this decoupled architecture where Indy is one possible solution that could be used on layer 1. And now Aries focuses on the agents and the credential exchange. Okay, so we have a general flow with Hyperledger Aries. There's usually an issuer, a credential issuer, a credential holder, and then a verifier. So each of these parties, each of these entities will be running an agent. So what this means, in this example, we have an employer who's issuing some credential, possibly proof of employment. And Alice here, the credential holder, takes that credential and generates a verifier representation and presents this proof to the verifier. The verifier is then able to validate that this proof is valid. And everything that happens at this credential exchange layer, the agents would go through the distributed ledger or the underlying technology and do whatever resolution of documents and verification of identities that are required. Now you look at this and you might think, okay, so what's the benefits of this over the previous flows with Bitcoin wallets, web-based Ethereum wallets? And the advantage really here is that there's a less need for the parties involved to have any idea about what blockchain is. So that really improves the experience, because with web wallets, what you'd have to do, the browser web wallets, all you'd have to do is, connect to your wallets, create a new account, create a seed phrase, store the seed phrase somewhere, figure out if you have a hardware wallet, and figure out how to connect that hardware wallet to the web wallets, and really go through all this learning curve. However, with this, you just have your application that already comes with an embedded agent and wallet, and those agents will communicate to whoever needs to be communicated with, and also handle the implementation of verifying and presenting credentials. So for example, if we were going to do this by skipping the Aries credential exchange layer, what would happen is that we would need to build, let's say if we were using Hyperledger Fabric, we would need to build an organization. So in our deployments, we'll have an organization that represents the employer. We also have an organization that represents the verifier. And we would have an organization that provides a service for everyone who's like Alice. So it's all of these organizations that will control the identity. The problem here is that now there's a reliance on one of these organizations for Alice's identity. If we're going to do this with Ethereum, then we'll have to deal with the slow loading times of transactions, the slow confirmation times of transactions. We'll also have to deal with the web-based wallets and checking transaction hashes to ensure things are done. And of course, dealing with gas, which is the unit of the payment unit to actually get your transactions to go through. So over here with Aries, all of that detail is abstracted away so that the client can just focus on what they need to achieve. Because in reality, no matter how technical we are and how good the system is from a software perspective, the customer really only cares about getting their job done. And if someone else can do it, then they don't need us. And that's a problem because we know from the software perspective that centralized systems have not been built to the advantage of everyday users. So this means our solutions, our decentralized solutions, must not only meet the performance of centralized systems, but also exceed them in user experience. So self-sovereign identity technologies give individuals and companies the ability to control and manage their own digital identifiers. That's SSI in a nutshell. So how do we get to this promised land? How do we get to this future? There's still lots of work that needs to be done. Of course, we know that looking at the technology adoption lifecycle, whenever there's a new technology, whether it's blockchain or AI or quantum computing, it needs to go through this lifecycle where is to first be tested by people who have no financial incentive to use it. They're only using that technology out of pure curiosity. Then you have the early adopters who would actually try to turn this into a product. The problem is getting from the early adopters to the early majority, because the early majority are the individuals and companies who have access to the mainstream markets, but they won't adopt the technology unless someone has already proved that there's some product market fit. So in order to cross this chasm, there needs to be a product market fit. This means not building solutions before understanding the problem, but actually thinking of ways to provide value and how blockchain technology will be useful in any of those ways. And of course, not just blockchain, but even the higher layer protocols like Aries. So what are some possible ideas to do this? We can really focus on the alleviation of pains by presenting credentials. For example, showing up to renew your driver's license, going back to school, calling people to get some documents when you no longer have their contacts, or maybe even those people who have stopped working with those organizations. There's all that pain of finding credentials and then getting them in a way that you can present them to people. And of course, with everything that's going on in the world today, we can see there's a lot of value from having a digital platform that can allow businesses to continue running their operations without people having to physically meet. So this means having lots of partnerships, because the reality is that blockchain is a team sport. There isn't just a group of software engineers in a basement or something that will write software and get it delivered to the world. We need to get out of the office, as Steve Blank usually says. We need to get out of the office and go speak to the customers. And of course, something good that many products have done is to embed services into their digital identity solution. So give people the opportunity to get their maybe credit reports and then convert it into something that can be presentable, also get their driver's license, and get access to different decentralized applications. So all of that is already being built. However, by onboarding more people and having more partnerships and alleviating the pains, I believe it's possible for us to get towards this future of digital identity. Okay, are there any questions? So that's it for the presentation.
Tomisin, the mobile agent Go thing that you're working on, do you have like the concept of a mediator for that? I've worked with the Xamarin one, and they have like a store and forward mediator. Do you do something like that?
Yeah, so the Aries Agents Mobile supports every controller that Aries Framework Go does, and one of that is the mediator. So there's messaging as well, there's out of band, there's a data exchange, present proof, issue credentials, and a lot more. So mediator is one of the bindings, is one of the controllers which are included in the mobile bindings.
Another question. So with the DID doc for sovereign and the resolver, it doesn't really resolve between different SSI networks. How do you see multiple networks working in the future, or do you think it'll just be one network?
Okay, let me understand the question. So you mean on a so sovereign, just for everyone, sovereign is one of these, it's a company that also has solutions for digital identity. And I believe they're a main contributor to Hyperledger Indy. So is your question that how can we prevent specific companies from being the sole controllers of how documents are resolved? Is that your question?
Well, because right now it's did solve, and if I set up my own Indy pool, and you set up an Indy pool, and I issue a credential on my pool, it's not going to show up on yours. So we have these sort of islands of networks, because we don't have a way of specifying which specific pool to use based on a DID. So have you been looking at that?
So I haven't looked into that, but if I was presented with that problem while working, what I'll try to find out is if there's a way, if there's some common thing that's some common components that both pools refer to. So if Indy is not just storing documents or whatever, if Indy has access to something, if it points to some other external registry, or if there's some other product or alternative to Indy that points to an external registry, then it could be possible to use that as sort of the general layer. But I think this is more of an implementation detail, but it's not something I've worked with.
Okay, so what network do you work with? Do you have your own network, or are you using the sovereign test network?
So one of the so something else being developed, another DID method being developed is DID trust block. Trust block is also, I believe some of the members are actually here tonight too. Trust block is an initiative, open source initiative that actually builds on Hyperledger Aries. So my work with Aries has mostly been with the development and extension of the platform to run on mobile devices. So I'm personally not running a network, but if you were to run a network, it will mostly be about finding out how to connect to some other um, uh, protocol at the bottom, so at the layer one, at the first layer.
Okay, yeah, because the problem I'm sort of trying to figure out is because the DID doesn't tell you which layer one network to use. Because you can have more than one network, like you have the sovereign main net, and you have a sovereign test net. If I issue a credential on the sovereign test net, I can't present it to someone as a credential on the sovereign main net.
Yeah, but I think, okay, so in that scenario, that might be a legitimate implementation, because even with something like Ethereum, if someone is operating a smart contract on a test network, they shouldn't be able to cross over assets or current or value or even currency to the main network. So it might be because in that specific scenario, they want to focus on separation of concerns with the data. So, for example, a main network is meant to be the production environment. So something on a test network really shouldn't be crossing over to the main network.
Okay, well, for example, I'm working on something called the Canadian Credential Network. So if I get the government of Ontario to issue a driver's license on the Canadian Credential Network, and if, let's say, the Bank of Montreal wants to use that, and they're using the sovereign network, then they won't be able to verify the credential, because the credential has it's got a DID inside it, which is going to point to the government of Ontario, which isn't going to sit on the sovereign network. Just do you see what I'm getting at here?
So the question is that the different data registries do not have, there's no interoperability between them.
Yeah, if there's multiple networks, there's no interoperability. And so we're starting to see regional networks poke up. Finland has one, Holland has one, there's a couple in Germany. There's Sovereign out of the US, and there's another one out of the US, I forget what they're called. But none of these are interoperable now.
Okay.
So it seems like this needs to be a problem that needs to be solved. I was just wondering if maybe your team was aware of some sort of work on that.
Yeah, it sounds like so interoperability has been a major issue in the blockchain industry. People have spoken about atomic swaps, moving assets all around, connecting different smart contracts. It seems we have someone raising a hand. So I think someone wants to contribute to the.
Hi, Dave. This is Troy, one of the Aries Framework Go contributors. Just to address that specific question, Aries Framework Go is not tied to a specific DID method. It supports generic DID methods in two ways. You can include your DID resolver code inside the framework, by injecting it into the framework when you instantiate it in your code. It also supports DID resolution through an external service. So you can alternatively configure the framework to reach out to a REST service and ask it to resolve the DID for you. So in that way, a particular agent can support as many DID methods as you wish. And we have tested it against several DID methods ourselves.
Okay, so if I created, instead of did solve, I had did something else, but it used the same type of way of resolving that solve does, like the internal information, then the agent should work fine with that. Is that the case?
Yeah, that's correct. So whichever DID method you that you're using, as long as that agent is configured to resolve it, it will get a compatible DID document back, and from there can find the keys that you have registered into the public keys that you've registered into that DID document. And the framework abstracts all of that. So at the end, you just get a parsed DID document back into the code that's using it. As an example of where we use that when we validate verifiable credentials. So our code will resolve the DID document, be able to extract the public keys, and then be able to parse verifiable credentials and validate the signatures that are on the verifiable credentials against the DID document.
Okay, so the trick would be to get into the universal resolver with whatever the DID spec that I use.
Yeah, so that's the easiest. So when you have it in a service like the universal resolver, that's the easiest to configure. There is some caveats that you probably might be wanting to run your own, so you can trust the code that's running on that service. That's certainly the easiest path. The other path is...
Oh, we're losing you, Troy.
Sorry, Dave, were you saying something?
We lost your audio.
Oh, I'm sorry. So I said the easiest way, yes, is to include the DID resolution capability into a service like Universal Resolver. The caveat is you should probably be running your own Universal Resolver or using it from someone you trust very much. The alternative is to include the resolver code directly into the framework so that your agent can natively resolve DID documents. And both of those integration paths are supported by the Aries Framework Go.
Okay, now is there because if new networks pop up, how do I become aware of these if I'm running my own resolver code?
So if new DID methods pop up, you would have to add that to your resolver configuration.
And how do I find that? I guess so. If someone presents to my wallet or my agent DID with a different method, I'm like, okay, great. And I go to my resolver, and it's like, I've never seen this before. So how do I discover these things?
So it depends on the DID method. If it's a DID method that's basically for a single network, you would have to actually add a new DID method to your software or to your configuration. If it's a DID method that supports discovery, and TrustBlock is one of those DID methods that can do that, it is capable of supporting multiple networks within the DID method. So it's kind of a choice between, do you automatically allow it to discover networks, or are you whitelisting or allow listing, I should say, the networks that it's allowed to discover.
One last question.
It comes down to a trust issue, right?
Yeah, and I'll stop dominating all the questions. So is the TrustBlock, do they have their own DID method, and can other people use that if it's got discovery as an aspect of it?
Yes, TrustBlock is a DID method. It is an open specification, and the resolution is open source. It's based on a decentralized identity foundation protocol called SideTree. So it's basically layering on the discovery aspects on top of the SideTree spec. Yeah, and it's open to use. Okay,
and would you recommend that instead of, let's say, did solve?
So that's a tough one for me to answer because I'm a TrustBlock contributor. So we did that method specifically so we could have discoverability on top of SideTree. And SideTree is a protocol that you can layer on top of any blockchain and distributed, decentralized content addressable stores. Like, for example, some of the DID methods some of the SideTree methods layer on top of Bitcoin and IPFS or Ethereum and IPFS. We've layered on top of Fabric.
Okay. Okay. Great. Listen, Troy Tomisin, thank you very much.
And you can actually find Trustblock on GitHub. So it's just github.com/trustblock as well. Okay. Are there
Going there right now.
Are there any other questions? Okay. If there are none, Alice, maybe so I can stop sharing, and then maybe you can.
Sure. Yeah. Thank you so much, Tomisin. Thank you for your speech, and thank you for all the questions, and thanks, Troy, for answering. And Dave, I'm really glad that this session is real beneficial, and I think it gets very technical. So yeah, thanks very much for attending the event. And if you guys have any, like in the future, if you want us to organize something like this, more technical, feel free to let us know. And if you guys have any idea, like which Hyperledger that you would like to know more about, or like in our future events, please feel free to share with us and complete the September survey. So everyone have a good weekend, and I'll see you next time. Yeah.
Thanks, everyone.
All right. Thank you.
Yep.
All right. Bye.
Thanks, guys.
Thanks.
Thanks, bye.
Thank you. Bye.